Welcome to Wildland Fire Behavior Fundamentals. You'll learn to identify the elements that make up the fire triangle, describe methods of heat transfer, list fire behavior terms used to describe fire spread, describe the types of wildfire, understand the fire intensity class system, list weather factors and understand how each affects fire behavior, describe how a slope influences the spread of fire, describe how the aspect influences a fuel's moisture content, and list topographical features that are barriers to fire spread. Let's get started. Three elements must all be present to start and maintain a fire. These are fuel, oxygen, and heat, known as the fire triangle. In a wildfire, the forest provides the fuel, the oxygen is in the air, and heat comes from an ignition source such as lightning or people. When one side of the triangle is removed, combustion cannot occur. This is the basic principle of fire suppression, breaking the fire triangle to stop the fire. When firefighters apply water to a wildfire, it removes the heat. When a bulldozer clears land down to mineral soil ahead of a fire, it removes the fuel. Heat energy is transferred from burning fuels to unburned fuels by three methods. Convection is the transfer of heat through the movement of hot air. Conduction is the transfer of heat through solid matter. And radiation is a transfer of heat in straight lines from warm surfaces to cooler surroundings. In a wildfire, all three methods of heat transfer can be seen. A pile of burning wood is transferring heat by conduction and preheating surrounding fuels through convection and radiation. Burning embers can be lifted upward by the fire's convection column and carried ahead of the main fire by the wind, resulting in spot fires. If embers still hold enough heat and land on fuels dry enough to burn, fires are ignited through conduction and radiation. Fire spread can be described as smoldering, creeping, running, torching, spotting, and crowning. A smoldering fire burns without flame and is barely spreading. A creeping fire is spreading slowly over the ground, usually with a low flame. A running fire is rapidly spreading with a well-defined head or advancing flame front. A torching or candling fire ignites foliage and flares up a single tree or small clump of trees from the bottom to the top. Spotting is the transfer of embers beyond the main fire perimeter, igniting new spot fires. A crowning fire ascends into the crowns of trees, spreading from crown to crown. There are three types of fires. Ground fires, or subsurface fires, exist in a fuel layer of organic material below the surface fuels such as peat moss. Surface fires exist on the surface, burning grass, brush, smaller trees, and other vegetation. Crown fires require a substantial surface fire to develop, but once the fire exists in the crowns of the trees, it spreads as a linked unit and is very hard to suppress. Fire intensity is directly related to flame length. The fire intensity class system relates levels of fire intensity with flame lengths and fire type. The longer the flame length, the greater the fire intensity. Note the difference between flame height and flame length. As the head of the fire is often driven by wind, the length will usually be longer than the height. There are 6 fire intensity classes. Intensity Class 1 has a flame length of less than 0.2 meters, typically classed as a smoldering ground fire or creeping surface fire. Intensity Class 2 has a flame length up to 1.5 meters, usually a creeping surface fire. Intensity Class 3 has a flame length of up to 2.5 meters, which is a more vigorous surface fire. Anything greater than a Class 3 intensity is not fought with ground resources alone. Intensity Class 4 has a flame length of up to 3.5 meters, which presents itself as a surface fire with torching and intermittent crown fires, depending on the fuel available. Intensity Class 5 is up to 5.5 meters of flame length, typically a crown fire. Intensity Class 6 has a flame length greater than 5.5 meters and will showcase extreme fire behavior. The fire environment that influences fire behavior consists of fuel, weather, and topography. Fuel layers consist of ground, surface, and aerial fuels. There are 6 forest fuel characteristics to consider. Fuel moisture content is the amount of water in a fuel. This will fluctuate as fuels either absorb moisture or moisture is evaporated. The wetness of forest fuels is influenced by weather factors such as precipitation or relative humidity. As fuels become drier, they are easier to ignite and encourage fire spread. Wetter fuels are difficult to ignite and decrease fire behavior. Fuel condition is the living quality of the fuels. In other words, is the fuel dead or alive? Dead fuels have the greatest impact on fire behavior as they are typically drier since moisture can be drawn out of them. Live fuels hold more moisture content and are typically less flammable, but that flammability can increase during periods of extreme heat and drought. Fuel size is broken down into three classifications. Fine fuels, also known as flash fuels or light fuels, ignite readily and are consumed rapidly by fire. It includes cured grass, leaves, needles, moss, and small twigs. They take on and lose moisture faster than larger fuels and are often where spot fires will start. Medium fuels are fuels too large to be ignited initially, but are small enough to be completely consumed. They include larger twigs, small branches, and other fuels between 1 to 7 centimeters in diameter. They require more heat energy to ignite but burn longer when ignited. Heavy fuels are large diameter wooden materials that are difficult to ignite, including logs, stumps, and trees greater than 7 centimeters in diameter. They dry slowly but burn longer with greater intensity when ignited. Fuel loading, also known as fuel volume or fuel quantity, is the amount of fuel on an area. Areas with greater amounts of fuel load available will burn with greater intensity. Fuel arrangement refers to the horizontal and vertical distribution of all combustible materials within an area. For example, ladder fuels provide a continuous layer of flammable vegetation between surface and aerial fuels that can grow a fire from the surface to the crown. Significant deadfall across a forest floor can allow for efficient horizontal fire spread. Fuel continuity or spacing refers to how close or far apart the fuels are over an area. A continuous arrangement has no gaps with close fuels, allowing for faster fire spread. In a patchy arrangement, there are well-defined gaps in fuels slowing fire spread. Fuels that are highly compact will combust slowly, but loosely packed fuels will burn faster due to increased oxygen and air circulation, drying the fuels. Of the three main components that influence fire behavior, weather is the most variable and has the greatest effect on how a fire will burn. Temperature, the degree of hotness or coldness of a substance, is important in assessing potential fire behavior. In particular, the relative ease of ignition of forest fuels. Temperature is affected by the season of the year, but more importantly, it is affected by the time of day. Temperature is normally highest during the afternoon, and the daily peak burning period coincides with this daily peak temperature. Relative humidity, a measure of the amount of moisture in the air, can have a big impact on potential fire behavior. When the RH is high, fuel absorbs moisture from the air, making them wetter and more resistant to burning. When the RH is low, fuels release moisture to the air, becoming drier and will burn readily. Fine fuels with more surface area respond quickly to relative humidity. When the relative humidity, measured as a percentage, falls below the ambient air temperature, measured in Celsius, it is known as crossover. Crossover can bring extreme fire behavior and usually occurs when temperatures are at their highest, typically from mid-morning to sundown. The presence of precipitation in all its forms, such as rain, hail, sleet, and snow, will result in a decrease in fire behavior due to fuels absorbing moisture and an increased relative humidity in the air. Light rain will soak into fine fuels but may have little effect on large logs, heavy timber, and deep duff. Short and heavy downpours may run off of fuels and not be absorbed. A light, steady rain over a period of time is preferable to a strong, brief downpour, as it allows the moisture to soak into the fuels. Wind is the horizontal movement of air relative to the surface of the earth and is the most critical weather element affecting fire behavior. It feeds oxygen to the fire and is also the most variable and difficult element to predict, posing problems for safety and fire control. Wind direction and speed must be constantly monitored by all firefighters. Wind affects the fuel drying rate, the preheating of fuels, the rate of fire spread, the direction of spread, the shape of the fire, and the creation of spot fire. As wind speed increases, fire intensity and rate of spread will increase dramatically. Thunderstorms can bring strong and gusty winds. Sudden changes in wind speed and wind direction will impact fire spread. Topography refers to the physical features of the Earth's surface. They can be both natural, as in mountain terrain, or constructed like roads. Topography is a constant variable in predicting fire behavior. For example, the slope of a mountain won't change. Slope is the upward or downward inclination, or slant, of the Earth's surface. On a slope, flames are tilted closer to unburned fuels, increasing convective heating upslope and preheating fuels. Fire will move faster uphill than on level ground as a result. When a fire is backing down slope, it will be much slower as there is less preheating effect and the flame front is angled away from fuels. However, burning material can roll downhill and ignite unburned fuel below the main fire line. Aspect refers to the direction a slope is facing. For example, a slope facing south has a southern aspect. The key importance of a slope's aspect as it relates to fire behavior is its exposure to the sun. How much sun a slope receives influences the temperature and the relative humidity on a slope, affecting the moisture content of fuels and influencing how easily they will ignite and burn. A southern aspect has more sun exposure, higher temperature, lower humidity, and drier fuels, resulting in more fire activity. They typically also have sparser, lighter fuels compared to northern aspect slopes. Higher elevations typically have cooler temperatures, higher relative humidity, increased wind speeds, and more precipitation. Topography can create wind and alter speed and direction of existing wind, such as within a valley or canyon. Always maintain situational awareness of the current wind conditions. Topographical barriers to fire spread include any topographic feature that stops or limits the spread of fire. Natural barriers include rivers, lakes, and rocks. Constructed barriers include roads, reservoirs, or fire lines constructed by fire resources. To summarize, the fire triangle is present and relevant in all wildland fires, and heat is transferred through all three methods to contribute to fire spread. Fire spread can be either very slow or very rapid depending on a variety of conditions, resulting in either a ground, surface, or crown fire. Fire intensity ranges from 1 to 6, and anything over a 3 or flame length of 2.5 meters should not be actioned by ground crews alone. Fuel, weather, and topography contribute to fire behavior, with dry, non-compact fuels burning the easiest. Wind is the most variable and most impactful to fire spread direction and intensity, making it the most dangerous factor when fighting a wildfire. High temperatures and low relative humidity can result in extreme fire behavior. Topography, specifically slope and aspect, will contribute to fire behavior as well. Stay safe out there, and thank you for watching.